Good morning and good afternoon, everyone, and welcome to today's webinar. Thank you for joining this event. My name is Sebastian Dziki, and I'm a chemist at Borchers Technical Service Department. I work a lot with alkyd paints, especially with replacing cobalt and MEKO from the formulations. And today, I will talk about how to improve sustainability with Borchers MEKO-free anti-skinning agents. I hope you will find this presentation interesting. So before I start, let me explain how this webinar will be handled. So all participants will be muted during the entire presentation. But if you have any questions, please use the control panel of GoToWebinar, which you should see on your right-hand side. And there is a section labeled questions. So please type in your questions during the presentation, and I will try to answer them at the end of this webinar. I would like to also mention that this webinar is being recorded, so after the presentation, you will receive both the recording and the slides. So I think we are ready to start. So in today's presentation, I will go over the MEKO replacement process. I will try to explain why this is an important topic, what is the current regulatory status, and what we can achieve by replacing it. I will also present you what is the Borchers offer for the MEKO-free anti-skinning agents and what benefits we can bring you into your paints. So later I will explain also the reformulation path of how to formulate MEKO out from your alkyd paints, and I will give you some formulation examples. At the end, we'll have a short summary. So why do we need MEKO-free anti-skinning agents? So there is a troubling concern with the usage of MEKO. Some nations have already proposed reduction levels of MEKO in alkyd paints, and those limits will be pushed further by the other countries and European Union. So the growing regulation concern with MEKO and cobalt and strong regulatory pressures pushed coating manufacturers to seek for alternatives and work on the replacement. But it's also important to mention that sustainability can be increased by using MEKO-free anti-skinning agents together with the high-performance catalysts such as Borchers Oxycoat and Borchers Dragon. So why MEKO is a problem? MEKO is now classified as a carcinogenic and a sanitizer. So we know that in Europe, this is a topic of interest and a high concern. And this is the reason why paint manufacturers are actively removing MEKO from their system. So the timeline for those changes can vary between countries and regions, but we know that European Union is working on it, and it's expected that the new regulations will be announced very soon. The other countries, such as United States and China and the rest of the world, are following those steps and regulations, and we can expect that they will announce new regulations soon as well. So the example which I am presenting on the slide here comes from Canada, and actually it represents the current official regulatory status, which includes the 3 measures to reduce the inhalation exposure from MEKO. So reducing concentration of MEKO to the lowest technically and economically feasible level. Also additional labeling. So there needs to be a ventilation statement on those products, and also more consumer education. So that means that now the manufacturers are also responsible for teaching consumers how to work with the MEKO containing products, and also how to take a good care of the ventilation in the closed rooms and areas. Like I said, this is an example from Canada, but we can expect to see more of the similar regulations coming from other countries too. There is also the toxicity and the corresponding labeling coming with MEKO. but also this new workplace exposure limit is really difficult to meet and pushes manufacturers to replacing MEKO in their formulations. Now we come to the next point, which is the Borchers offer of the MEKO-free anti-skimming agents. As you can see here, we have 5 different products which are completely MEKO-free, but we can divide them into 2 groups. So first, there is a asthinin line, which gives you the best regulatory position, as they are not only MEKO-free, but also oxime-free and phenol-free. So they are based on the amino compound, and we offer them in different solvents and also different volatility. And then we have the 2 products which are based on the oximes. So we have a Borchers 1640, which it's based on the cyclohexanol oxime and have a minimal impact on drying times. And then our newest product, recently developed and launched together with our Borchers Dragon, so a Borchers Shield. This is also oxime containing anti-skin, and also it has a minimal impact on the drying performance. So now let's have a closer look onto these products. So asthinin anti-skin line, they are highly effective antioxidants for the oxidatively drying coatings. They are specially designed to work with solvent-borne high solid alkyd systems. So they are recommended to be used with our high-performance catalysts such as Borchers Dragon and Borchers Oxycoat. But it's important to know that the optimum level needs to be experimentally determined. This is not one-to-one replacement for MEKO, and overdosing those anti-skins may lead to the extended drying times. So the reason for that is they actually work differently than conventional oxime-containing anti-skins. So the asthinin products go into the system, into the film, instead of just sitting on the surface and creating this headspace barrier for the oxygen, like oximes do. And thanks to that, they are also less sensitive for like frequent opening of the containers with paints. So the recommended dosages here for the 0444 and 0445 are from 0.2 to 0.6%. And for the 1240, the dosage can go higher up to 1% due to its higher volatility than those other 2 products. Then we have our Borchers 1640. So like I said, it's based on the cyclohexanol oxime. It has a even higher volatility than the asthinin products, and in the same time, it has also minimal impact on the drying times. Then last but not least, we have the Borchers Shield product, which is our newest addition to the anti-skinning group. It was specially designed to work synergistically with our Borchers Dragon and to prevent skinning in a high solid long all alkyd system. It can be used as well with the Borchers Oxycoat. So this one is also oxime containing anti-skin, so the volatility is also higher than with the asthinin product, and also the impact on the drying time is minimal. Now I would like to talk about another important issue. So why is it worth to replace cobalt and MEKO together? So I talked already about the MEKO, but what is the situation with cobalt? So cobalt also faces strong regulatory pressures. We know that cobalt and its salts are classified as carcinogens, and they will be regulated out of use. So that means that having cobalt in the formulation will lead to the labeling, which of course this is something every coating manufacturer would like to avoid. But there is more than just only regulatory pressures and labeling. So the big advantage of replacing cobalt is the improvement of the general performance of the system, which can be ensured with the high-performance catalysts such as Borchers or Borchers Dragon. But this is also very important to mention that cobalt works well in a combination with MEKO. But to replace MEKO with a different anti-skin agent, the new evaluation is necessary, as there is no one-to-one MEKO replacement. And another thing which also should be taken under consideration is that the cobalt alternatives work differently than cobalt dryers. So again, there is no one-to-one replacement here. So that means that another anti-skinning evaluation is necessary. So that brings the conclusion that if we will do both replacements at the same time, we will actually need only one reformulation process instead of two. So now let's move to the potential reformulation path. So there are two ways to consider. First is just a MEKO-free option. It gives us labeling MEKO-free, but of course we need to do the reformulation process for the new anti-skin. But also we should keep in mind that we will have to face another reformulation in the future to remove cobalt, which actually comes down to a double work. Now let's move to the second path, which is MEKO-free, but with combination with high-performance catalyst. So this solution gives us MEKO-free and also cobalt-free labeling, but also at the same time, we are enhancing the performance of the system, and we can bring complexity reduction and all that in only one reformulation process. I would like to focus now on the first path, which is replacing only MEKO. That means that we still have a cobalt in the system. So how to run the anti-skinning evaluation? So on the slide, I'm presenting actually the method which we are using in our lab. So basically what we do is we run a small ladder study for every anti-skin to determine the optimum dosage. So for actinin 0444 and 0445, we recommend to test the dosages from 0.2 up to 0.6%, while with 1240 and the Borchers Shield, we advise the range from 0.25 up to 1% due to the higher volatility of those products and less impact on the drying performance. So from every sample, normally we prepare 2 drawdowns for the drying recorders to verify drying times, and then we evaluate skinning performance. So moving to this evaluation of skinning, this is a standard method which we are using in our lab, but I would like to mention here that when we work with the customer project, we always try to adapt to the customer's method to have a most comparable results and to be as close as possible to the method customer is using. But in our method, we normally start, of course, with preparing the samples first, and then we leave those samples overnight in the plastic FlagTech cups, FlagTech containers, to verify if skinning will appear within 24 hours. So of course, after this time, after 24 hours, when we find samples with skin, they are eliminated from the testing, and the rest of them we placed in glass vials with around 1 inch headspace, and we place them in the oven for 50 degrees Celsius for 2 weeks. Then after 1 week, we check those samples, but we do not open the containers. We just trying to judge if there is a skin or not by just tilting them. And then after 2 weeks, we open the containers and we evaluate skinning fully, and we also examine the sample for any color change and etc. So we have our own skin rating system. You can see it here in the table. We use numbers to describe skinning from 0 to 6, where 0 means that there is no skin at all, 5 means that there is a hard skin, and then 6 for us corresponds to the gelling, which can appear throughout the cam. So now I would like to present you an example of the formulation where we replaced MEKO with one of our anti-skinning agents. So let's first have a look on the formulation. So the dryers package here contains cobalt, calcium, and zirconium, and also we have 0.3% of the MEKO. So we were able to successfully replace MEKO with 0.5% of our Astin 1240. And if we look at the two small graphs on the top of the slide, we can see that this change of the anti-skin did not cause any discoloration. So the L and B values are very comparable and on the same level between the supplied control, so the control formulation, and our solution with 1240. But the graph below presents the drying times in the standard conditions, so initially in standard conditions and also after stability. And actually we can see that by changing the anti-skin, we are able to improve drying time of the system from 4 hours, which has a control, to 3 hours, and still maintain and keep the same good stability. So let's move now to the second path, which involves introduction of high-performance catalysts and allows us to replace not only MEKO, but also the cobalt dryers. Before I start, let me introduce you in a few words our high-performance catalysts. So this is our patented organometallic ligand technology, which provides an excellent drying performance. We have our Borchers oxycode, which comes in few versions, and then we have a then we have also the Borchers Dragon. So the Borchers oxycode product is supplied in different solvents. There is a version for waterborne and solvent-borne systems. And then Borchers Dragon is our recently developed catalyst, which is designed especially to work with long oil, high solids systems. So a few key features and advantages of the high performance catalyst over conventional cobalt dryers. So they dry faster than cobalt, and they provide excellent drying performance under adverse conditions. They also do not cause yellowing over time, and also we see that initially they give a better color. And they also can reduce the need for a secondary dryers and provides a good drying in the thick films with non-wrinkling. So as we learned a bit more about the high-performance catalyst, I would like to now move to the evaluation process. So there are 3 main stages to that process. First, there is a ladder study of the high-performance catalyst. So what we do here, we evaluate them in the system alone, with different dosages to find the optimum level. Once we find that level, we move to the second stage, which is evaluation of the secondary dryers. So this step is optional, as it depends if there is any need for the secondary dryers. Like for example, if we want to improve the storage stability, then we can test the calcium addition at a few different levels and so on. So again, like a small additional study to evaluate secondary dryers. And then after that, we move to the final and the last stage, which is the anti-skin evaluation. So this process here, it's exactly the same as the one I presented for the previous reformulation path. So we look at different dosages of those different anti-skins and try to find the best, the optimum level and the best working solution. So once this solution is found, then we have a cobalt-free and MEKO-free formulation ready to go. So similar to the previous part, I'm going to present you a few examples of the formulations where we have successfully replaced the MEKO and the cobalt. So this system here is based on the Arkema Sinolac resin with 90% resin solids, long-haul alkyd. So this system is solvent-borne, meant to be used for decorative. So let's have a look on the formulation here. So the dryer package, the control formulation, contains a blend of cobalt and zirconium. There is also calcium in the system and 0.3% MEKO. So what we did here, we were able to replace not only cobalt, but actually cobalt and zirconium with only adding Borchers oxycoat in the system. And we replaced also MEKO by adding 0.5% of actinium 1240. But the key formulation advantage is not only removing cobalt and MEKO, but also is the performance. So if we look at those on the graph on the top, we can see the comparison for the samples with the control samples and the formulation containing Borchers oxycoat. So this is the drying time graph, and we can see here that control formulation actually needed 17.5 hours to reach this final stage of drying, which is a dry hard. While this formulation with our solution with Borchers oxycoat and actinium 1240 is able to dry within 10 hours. So actually we are able to improve the drying time and decrease it from 17.5 hours to around 10 hours. But not only the drying time was improved, that's also one of the key formulation advantages here is the color. So if you look at the second graph below, then we can see the comparison between the control formulation and the formulation with Borchers dryer and anti-skin. And we look at the B value. So that's the value which give us show us the yellow undertone. So we can see here that the control formulation with cobalt was even more yellow, even if we look at the initial values. But then what happened after 2 months at the dark, being stored for 2 months in dark, it really showed us the huge improvement. So when we see at the control formulation, we see that the yellowness, this yellow undertone actually increased significantly, almost twice. While if we compare the Borchers oxycoat solution, we see that the color changed only very slightly and it remained stable. And if we look at the pictures below the table, there is those are the pictures of the panels we took from the samples which were stored for 2 months. And I think it's really visible here and clear that the color of the cobalt formulation, it's much more yellow than the formulation with Borchers oxycoat and our actinium 1240. So here I have another example. This one is for the general industrial coatings, and we have here a short oil alkyd made for a splay application direct to metal. What we did here in this system, we actually provided customer 2 solutions. So one is just replacing cobalt and keeping MEKO in the system, and the other one here in green, it's a solution with no cobalt and no MEKO in the system. So they both got replaced. So if we look again on the formulation here, the dryers package contained the cobalt, zirconium, calcium, and 0.5% MEKO. And what's interesting here, when we just used the Borchers Dragon, so we kept the MEKO in the system, we're able to again replace not only cobalt but also zirconium. And if we look at the dosage of MEKO, we were able to actually cut this dosage in half. So we were able to provide a non-skinning solution with a lower dosage of MEKO. And if we look at this formulation in green color, so that's the best formulation, as it do not contain cobalt or MEKO. So we used exactly the same amount of Borchers Dragon, and then we combined it with Borchers Shield here to get the cobalt-free and MEKO-free formulation. So again, let's look at the performance. So the graph on the top show us the drying time. This time it's in minutes because that's a short oil alkyd. And we can see a comparison between drying times in standard conditions in red color, and in gray color we see drying times in adverse conditions. So here it was 10 degrees and 80% relative humidity. So we can see here that in standard conditions, all formulations have a similar comparable drying times. But if we look at the adverse conditions, then we see that the cobalt-containing formulation really struggles here to dry. So the dry time extended here more than double. And if we look at the formulations with Borchers Dragon, then we see that both with MEKO and with MEKO-free anti-skin, we actually were able to significantly improve drying in adverse conditions, and thanks to that also provide a stable dry time. So that means that we don't have a gap in the performance between the standard conditions and the adverse conditions. But again, here with Borchers Dragon, we are not only bringing the performance benefit in drying times, we also see the improvement in color. So this time here we are comparing the initial values of that B value here, and we see that the control formulation with cobalt, it's significantly more yellow initially here than both formulations with Dragon. So again, we do not only replace cobalt or MEKO from the formulation, but it's very important to know that we can at the same time also improve the general performance of the entire system. And here there is a last example. So this system was for the wood coatings. It's a wood stain designed to work to be used in interior and exterior wood. So the formulation here, as we can see, the control contained manganese, cobalt, and zinc, and also there is a dosage of 0.2% of MEKO. And what was very interesting here, we were able to replace all of those dryers. So we replaced manganese, cobalt, and zinc just only with a small addition of Borchers Oxycoat. And what's even more surprising, I would say, and it's really important to highlight that in this formulation we didn't use any anti-skins. So this formulation is actually anti-skin free. And if we look at the performance on the graph, then we can see that we improved again the drying times significantly compared to the control. So the control samples here dries. We showed dries within 24 hours because this is what we measured at our recorder, but the sample was still not dry, so it's even higher than 24 hours. And with our solution, with Borchers Oxycoat in the formulation, we were able to dry this product within around 9 hours. And on the pictures below, we can see those are pictures of the panels of the Jordans after the drying recorder, after the drying time test. So we use the circular drying recorders, not the linear, but the circular. So the mark on the panel builds a circle, and if you look at that control sample, we see that the full circle is visible. And because the recorder was set for 24 hours, that means that within this 24 hours, the paint still remain not dry. And if we look at the second picture on the right hand side, this is the formulation with Borchers oxycode, and we can see here that there is this mark on the panel actually stops, and we cannot see any mark further. So that means that this coating here, the sample here, was dry. That case, in less than 10 hours. So I would like to end with a summary of a main point. So it is very important before the reformulation process to determine the path, whether we want to go a MEKO-free or a cobalt-free and MEKO-free. We should also keep in mind that there is no one-to-one MEKO replacement, so the evaluation process is needed to find the optimum dosage of the anti-skin. And also that replacing cobalt with our high-performance catalyst, thanks that we can not only comply with the regulations, but also we can improve the general performance of the system, bring faster drying times in standard and in adverse conditions, as well as a better color and no yellowing over time. I would like to also mention that we, as a technical service, we offer direct support to our customers. It could be via trainings or webinar like this one, but it can also include the formulation optimization in our lab, of course, after agreeing and discussing the details of the cooperation first. We have fully equipped lab, and we are confident that we can meet our customer needs and the requirements. So thank you very much. That is all what I prepared for today. Thank you for your attention. And now I would like to move to the questions section. So please, if you have any questions, now you can type in that section on your right hand side. So I have a question here. When is the regulation of MEKO and cobalt kicking in? Actually, we don't know the exact dates of when those regulations will come live. It can vary from countries and regions. So we know now that the European Union is really working on it and pushing it, and we really expect that it will be announced soon. So what I can say is that we know that many manufacturers set a goal for themselves to remove MEKO completely from the system by the end of this year. So also I have a question regarding the last example I shared. So the question is, because we had only Borchers oxycode in the system and no anti-skin, so the question is the Borchers oxycode served as an anti-skinning agent in that formulation? So let me just go back to this slide. It will be easier to obtain this behavior. So this is the formulation I'm talking about. So here, this is the wood stain. So those products typically have a also high amount of the solvent inside, and we found a few times already that in those kind of products we can avoid adding the anti-skin in the formulation. So Borchers Oxycoat works a little bit different than a cobalt dryer. So the cobalt dryer has a very strong surface drying, while Borchers Oxycoat dries, I would say, more equally throughout the film, so not only on the surface. That's why in some systems with like wood stain, for example, when we have a lot of solvent in the system, we can confirm that we don't need an anti-skin additionally in this formulation. Of course, that depends on the system. It's not like in every system it works the same way, but I can confirm that a few times we've seen this this pattern here, that in the wood stain we can actually proceed only with, for example, Borchers Oxycoat. So I have another question here. How much will an anti-skin affect the drying with the high performance catalysts? Like I explained when I was talking about the anti-skin agents, so it depends on the type of the anti-skin. So the oxime-containing anti-skinning agents work a bit differently. They have a higher volatility and they do not impact the drying time significantly. When we look at the other group, so then our acetylene line, which is an amino compound-based product, like I said, they go to the film, they stay in the film, and that's why they do not, let's say, sit only on the surface, and they may, when overdosed, they may lead to the longer drying times. But what we found is that's a very system dependent. In some systems, we see that this impact of the drying of the anti-skin, it's much lower than in other systems. That's why we always say that it needs to be experimentally determined the right level. We cannot just say that, for example, 0.5% will work best in every situation and in every system. So I have also a question if those dosages were in percent of the resin solids calculated on the resin solids. So the values I'm showing here, we are showing on the 100 gram paint. So this is the actual amount of the dryer or of the anti-skin which you are putting into the system. Sometimes we calculate those high performance catalysts on resin solids in the paint, so not just the resin solids, but the final resin solids in the paint. But here in that presentation in these tables, I showed only the values which are like the real dosage we are putting on the 100 gram paint. So I have another question, if we can replace Borchers Inox 1640 with MEKO 1:1. Like I mentioned a few times in this presentation, there is no 1:1 replacement for MEKO. And Borchinox 1640 has is also oxime containing, but it will be also no one-to-one replacement. So in every case here, there is a need for an evaluation and testing at least a few dosages of that anti-skin to find which one works best in the system. So thank you very much for taking the time to listen to my presentation. If you have more questions or seek additional information, please feel free to contact us directly, or you can talk to your local distributor. So once again, thank you very much for taking the time to attend this presentation, and I wish you all a great day. Thank you.